Hi. Welcome to the talk about mjprof. It's a monadic JVM profiler. I'm Chaim Yadid, and I'm an independent performance expert. In the last years, I've been consulting R&D groups and also trainings about Java performance. I'm also one of the community leaders of Java IL. So if you happen to come by in Israel, we have 400 members and we meet up every month. So you probably never heard about mjprof, so the talk is going to be like that. I'm going to describe the problem and then have a brief review on the features that it has, and then we will have 10 recipes of things that you can do with mjprof. So let's start with a bit terminology and make sure that we are all on the same page. So the two most important questions my wife asks me is, what are you doing and when are you coming back? And basically that's the questions that we ask our software all the time. What are you doing and when you're going to finish what you're doing? And the tools that help us to answer these questions are called profilers. They are tools that enable us to look on methods and ask questions about them. How much time it will take them to end, how many cache misses, memory allocation, etc. That's what profilers do. Roughly speaking, from the technological aspect, there are two kinds of profiler. The first one, called statistical profilers, they're actually sampling the process every period of time and trying to see and understand what it is doing, assuming that it continues to do the same between the sampling. It is not very accurate, and it gets the information along the way in statistical manner, so it is not very good for short tasks. The other kind of profiler is called instrumenting profiler, and it is actually changing your code. It puts some code at the beginning of the method and in the end of the method, and it actually measuring what happens between these two. If you're not using an instrumenting profiler in a good way, then you may be stopping your process and causing real performance problems, because instrumenting everything is very bad. Okay? So we have sampling profilers and instrumenting profiler. And one of the most common profiler for Java processes is called Jsoc. Actually, it's not a profiler, it just takes a thread dump of all the threads of your process. But the fact that it is able to do it in any case, in most cases, and it's very available, it's part of the JDK, makes it in some manners a poor man's profiler. So after you take a thread dump, you get some kind of textual snippet for every thread, and you can see for each thread what is the stack of it, and the name, the priority, the ID of the thread, and the native thread ID. And it's really cool. You are able to find a lot of problems with Jsoc. The problem happens when you have many threads and deep stacks. It's really getting nasty. You have a lot of information that you need to dive into, and it takes a lot of time. So this is where mjprof comes into the play. So what exactly mjprof is? mjprof is a command line tool that acts on the output of Jsoc. It also extends it over, but basically it's only acting on it. And given an input of Jsoc, it can filter threads, it can aggregate threads, and it can manipulate the stacks of the threads. So what do you need to have in order to run mjprof? Only a JDK. You can manage with a JRE, but for some of the functionality, for example, attaching to a process, you will need a JDK. It can also run on a headless machine. You don't need a user interface, though there is some GUI capabilities of it. Installation is quite trivial. I will not go into it. But once you've installed it and put it into your path, you can run a smoke test, run mjprof and see if it prints a synopsis. If it does, it means that it works. So running mjprof is nice, but what can you do with it? The first thing that you need to understand is that you have some kind of an input to your mjprof application, and then you apply a pipeline of basic building blocks that are called monads. The monads can collect data, they can filter out certain threads, they can transform the information in thread, and they can aggregate. And at any point you can take snapshots. So if you have a very long pipeline of operations, you can take snapshots in the middle, okay, and continue from there. Concatenating monads is done by putting a period. mjprof is defining some kind of a DSL, but it's only a single line of a program which fits into the command line. So let's have a short intro of what kind of monads we have. First of all, we have data sources. The most trivial data source is standard input. You can direct the output of Jsoc directly into mjprof, or you can cat thread dump or previously taken into mjprof. The second way to get the data is from a file. You put the monad path, and then you pass it a parameter with the name of the file that you want to get. So, by the way, passing parameters to monads is done by 2 forward slashes. It's the only character that is not used by UNIX, so I choose to use it. The other thing that you can do, you can run a monad called Jsoc, which actually imitates what Jsoc does. It connects to a process. You don't have to put a process ID. You can give the main class name as well, and dumps the thread dumps of the process. And of course, you can also connect via JMX, which means you can connect to a process on this machine or on a remote machine. And after that, you can apply any one of the following monads that are already available in mjprof, or if it doesn't fit to your needs, there are 2 ways to extend the functionality of mjprof. The first one is macros, which is actually concatenating a set of monads that you found to be useful. But you can also write plugins. There is an API. If you develop a plugin, you can create a jar and put it in the plugins directory, and you're ready to go. Okay? It's very extensible in its nature, because as we try using it, you will see that for your needs, you may need additional functionality. Okay, so that's a basic description of what you can do with mjprof, but it's a little bit obscure, I guess. So let's take a look on some kind of recipes or things that you can do with mjprof. So the first question we want to answer is, for example, how many threads I have in my process. So I run mjprof, and then I can either give it a stack from a file, or I can attach to a process number 1971, or I can attach to a class a process which has the main class, and I get a thread dump. And then I concatenate a period and a count, and I will get the number of threads in the process. It sounds really silly, but we're just warming up. The second question that I would like to ask is, for example, how many Jetty threads I have in my process at the moment, and which one of them are running. So I will run mjprof. It will get Jsoc monad as a data source and my app as the main class, and then I will ask whether the name of the thread contains the string QTP. And after that, I will also ask about the state of the thread, and it should contain run because I want only runnable threads, and that is the result. Okay, I get only the threads that are containing the QTP in their name and run in the state, and then I can count them again. Okay, and get the number of such threads. Recipe number 3. The question is, which thread are running my logic? A lot of times you will have an application server that has tons of threads. Not all of them are relevant to you. It can be only a handful of them, but you want to filter out all the others. So you run mjprof, and you of course grab the stack trace, and then you query the stack parameter for a certain application. And then threads that do not have in the stack the name of the application, for example, in the package for a company, etc., will be filtered out. Another question that we have many times is that we have stack traces that are huge. Many frameworks like application servers, JBoss, Tomcat has, before you start, you're in like maybe 50 stacked frames that are really not relevant and not helping you understand what's going on. So you want to filter them out. You run mjprof again. You collect, this time I collect the information via JMX. And I want only the frames that contains information of my company. Okay, that have my company in the package name or in the class name. Or I can ask to filter out. By the way, minus is always, when applicable, is always the opposite of what happens without a minus. Okay, so if you have a frame that includes only stack frames that are relevant for me, minus frame will filter out all the frames of Grizzly, because I guess that the problem is probably not there. Or if I really want to look only on the top of the stack, what's happening lately, then I can only look on the 3 last stack frames. That's very useful, actually. Another question that we can ask ourselves is, I have a lot of threads, and I want to group them by state. I want to see what the threads that are in, for example, in status waiting are doing right now. Okay, so this is where grouping comes into hand. mjprof can actually combine several stack traces into what is called a stack tree. Okay. So I can take a thread dump, and then I can group by state, and all the threads will be divided by the state of their in, and I can then throw it into a monad called GUI, which will open a Swing UI and display it in a tree. Okay, so I have some kind of an aggregated view, which actually what makes mjprof a profiler. In addition to that, mjprof consumes all the thread dumps you're giving him. You're not bounded to a single thread dump. You can take several of them, and it can actually do it for you. The following example is running a JMX monad, which actually connects to a process and grabs a thread dump using JMX, but it does it 10 times in a row and slips 1 second between the samples. And after I do that, I apply the monad merge, and the monad merge actually combines all the thread dumps by a certain attribute. The default attribute is the thread ID, which means that after that, I'm able to see what a certain thread does in all the consecutive samples that I took on it. And of course, I can follow on the result. I can again group it by state. Okay, so as I said before, mjprof consumes many thread dumps, and what's nice about it is that you can consume thread dumps from different processes. For example, if you have 10 machines and you want to get an overall behavior of all your JVM processes and all of them, then you can do the following. You can connect to one of them and grab a thread dump, and you connect to another one of them and grab a thread dump, and then you can group by any parameter that you want and display the result in some way. And the reason that you can do it is because mjprof is actually running a pipeline of threads that each one of them runs separately. So actually what will happen is that it will access these two servers at once. Okay, and when it will have the thread dumps grabbed for them, it will squeeze it back, squeeze it forward in the pipeline to the next operation on them. So one more thing that you can do with it, and this is actually something that really bothered me a lot of times before I developed mjprof, is that you want to be able to measure CPU consumption of threads, but you want to take a look and see what happens in many threads at once. So, for example, you have some kind of a thread pool, and the thread pool has like 50 threads. And the 50 threads are doing some work, and each one of them is consuming 1% CPU, 2% CPU, and they want to understand whether the entire thread pool is causing some kind of CPU problem. So for that, there is a different monad. It's called JMXC, which in addition to grabbing stack traces using JMX, it also uses JMX to measure the CPU consumptions of thread. So it actually measures CPU consumption in the beginning, then takes a thread dump and measures CPU consumption again in the end. And it is able to add information about this CPU consumption within this time interval. So if you take the JMXC and grab a thread dump, it will have additional information. And then you can focus on your thread pool, which is named coffee. And I also use the monad -pkj, which throw away the package from the stack frames because it just makes things long, and then group it by together, all of them together. Then I will be able to see how much CPU my coffee thread pool is consuming within this time interval. Okay? That's really cool. And going back to some kind of locking and concurrency issues, if, for example, I have a thread and it blocks other threads, and I want to understand which threads are blocked, of course, I can take Jsoc, and with Jsoc I can find the threads that are waiting for a certain lock. But if I have 1,000 threads, it will be really hard. So I can run mjprof with the thread dump that I already have, and look and try to find threads that are blocked, and also contains in the stack the pointer of the lock that I'm looking for. Okay, and that filters out everything that is not interesting for me. Another thing that I can do is to try to understand the overall locking state of the application. Okay, so I have a lot of threads. Each one of them has a very long stack trace, and I really want to be able to focus only on locking. So I take my thread dump and I check whether it contains my code, for example, my application, and then I run the monad locks. The monad locks is a macro which is looking for the minus sign in the beginning of the stack frame. Okay, so it will filter out all the stack frames that do not have the minus in the beginning, and the result is that I will only see the locks over there. Okay, I want to show you a nice example about real-life production problem that I was able to tackle with mjprof. So I have here a stack trace called bad stack trace. And here it is very long. And I will feed it into mjprof path bad stack trace. And first of all, I want to filter out all the threads that are not related to my application. As a matter of fact, I don't remember what is the name of my application because I changed it. It's a real production code. So it's called my company at the moment. So I will run the monad contains, and we are looking on the stack, and we are looking for my company. And now I have only, oops. Contains. Thank you very much. Okay, so now I have only the threads which contains my company code, so I can count them. I have 24 of them. I already know what is the problem. The problem is that it also runs Hazelcast code. Actually, it's a production problem where Hazelcast got stuck on one of the server. It was like waiting for ages for it. So let's see which threads also contains in the stack Hazelcast. So that's and count them again. We have 21 running Hazelcast, and then we can also group them, and then we get some kind of a tree, a very clumsy tree, which shows all the threads, like a distribution of how it spends the time. But we can also run GUI, and it will open it in a user interface. Okay, so I can try to find out what is the behavior of this application. And eventually, what I will do with it, I want to throw locks and see if it behaves better. Yeah. And group it again. Okay, so now it gets a bit shorter, and I can see where my threads are spending that time. Okay, it's boiled down into some kind of code which is Hazelcast API, wait for response. Okay, so that's a demo of what can we do with mjprof. If you have questions, that is the time. So before, does anyone have a question? Yeah. Does it work on Android? No. If you grab an Android stack trace, I think, and it looks the same way Java stacks look, then you can also feed it with it. I've never tried it with Android. It is part, by the way, it's part of AdoptOpenJDK. It's open source and free. You're welcome to use it as you wish. Any other questions? Yes. Okay. Yes.
Same question for IBM JVM.
I've never tried it with IBM JVM, but if you will send me stack traces, I would love to make sure that it supports it. Basically, there is no reason why it shouldn't. Okay, great. So thank you very much. If you don't have any other questions, then